All right, number 7, we want to find the antiderivative of f of y, which is equal to a negative 3 divided by y to the 4th. So instead of trying to do antiderivative with quotient rule, I like to rewrite any exponent in the divisor as a negative exponent. So I will rewrite this first as a negative 3 times y to the negative 4th power, and then we'll use the power rule. So remember, the power rule is going to add 1 and then divide by that negative 4 plus 1. So doing so will give you a negative 3y, and then a negative 4 plus 1 will give me a negative 3, and then I will be dividing by negative 3. Negative 3 divided by negative 3 is 1. So my antiderivative is just y to the negative 3rd. If I write this as a positive exponent, you got to think there's an understood 1 as a coefficient. I'm only going to move the negative exponent down, so this is going to be a 1 divided by y to the 3rd, and then don't forget your plus c. Hopefully I'm still on my page. So that'll be a 1 divided by y to the 3rd plus c as our integral. All right, antiderivative e to the x. So we have 16 e to the x, okay? And we want to find big F of x. So we're going to be integrating. We'll pull out the 16, and we're going to be integrating ex with respect to x, okay? Derivative of e to the x is just e to the x, so the same thing, integral, it's going to just be e to the x, but we'll have our plus c. So we'll just end up with 16 e to the x plus c when we integrate e to the x. Now the thing we need to be careful of is sometimes if there's an argument in the e to the x, we multiply by the derivative of that. The common or the equivalent form of that will be dividing by the derivative of that function. In this case, we just have 16e to the x plus c.